Yeah, good morning, dear students. So this is Dr. Vijaya Babu. So we are deeply discussing about the concepts of current electricity. In the last lecture, I think I have discussed about the Kirchoff's voltage law. So now today we'll try to go ahead with once again the continuation concepts of Kirchoff's voltage law. So previous discussion, what I have made is you can remember this is the slide what I have made about this Kirchoff's voltage law. So here I have divided the law into two things. So one is Kirchhoff's voltage law 1, whereas Kirchhoff's voltage law 2. So Kirchhoff's voltage law 1, what I have defined is the potential difference between any 2 points is independent of path taken. Okay, so that is the thing what I have explained about Kirchhoff's voltage law 1. Whereas about the Kirchhoff's voltage law 2, so the algebraic sum of voltage in a loop is exactly equal to 0. So the concept what I have explained here, so I have done only by taking the points, individual points, and the potentials at the different individual points. Now today we'll try to go ahead the same extension of the same topic by considering a small loop. Okay, loop means compulsory you must make a small battery, a resistor, like that. So and you'll try to make some series combination or else parallel combination. So in that context you'll try to go ahead to understand the concepts of KVL. Okay, so before going ahead, so one simple example what I would like to tell you is about the KVL. Kirchhoff's voltage law. So see here, for a valid KVL, if at all I connect three batteries in series, something like this. So if this is plus or minus 10 volts, okay, so this is something minus or plus, let it be 20 volts. Now this voltage minus or plus, so I don't know the value of Vx, so I'll try to calculate the value of Vx. Okay, so in this context, to calculate the voltage across this battery, that is to calculate what you call it as Vx. So to calculate Vx, it is my target using KVL. So is it required to calculate the current through the loop? That is the current passing through this 10 volts battery, 20 volts battery, Vx. However, it is a simple loop and all are connected in series. I can say that same current will run throughout this loop. The current is simply I. So the point is to apply the KVL in this loop. Is it required to calculate the current I? First important thing what we have to notice is the current calculation is not at all required. So the current through the loop is not at all required. That is the beauty of KVL. Okay, the KVL, now I'll try to go ahead in applying the KVL. The KVL is very simple. So KVL in the loop. So simply the application of KVL, how you need to apply the KVL, you need to think like this. So you'll try to start from at this point. Okay, so you start at this point and you keep on walking throughout the loop, something like this. And once again you reach the same point. So this is very important thing, and this is the first thing what you need to understand to apply the KVL. Okay, so that means you have to walk along the loop and you should come back to the same point. That means you have to complete the closed loop. It should not be any open loop to apply the KVL, because what the KVL is saying, the algebraic sum of voltages in a loop. Loop means always it is a closed one. Okay, so in a loop is exactly equal to 0. So this is what the KVL is saying us. So without calculating the current I, directly you can apply the you can calculate the value of Vx by walking around the loop. So you start walking around the loop. Once you reach this point, what you're touching negative terminal of the 10 volts battery. So if you're touching the negative terminal of the 10 volts battery, first you need to consider minus 10 volts, because you're touching the negative terminal first, na? Then you are walking ahead and you are walking like this, you are walking like this, once again you're touching what? You're touching the negative terminal of the 20 volts battery. That means negative terminal of the 20 volts battery. Okay, then you're going ahead, you're moving ahead, you're walking in the loop, and finally here you are touching the negative terminal of the VX battery. So if you're touching the minus negative terminal of the VX battery, then so what you are touching first, that you need to take that as the note, that as a sign. Okay, so then you walk and come back to the original point. So now I think you have done the algebraic sum of the voltage in a loop, you have added them, then this value must be equal to 0. So this is what KVL will always say us. So when you know, if at all there are three different voltage drops, if you know two among them, easily you can calculate one drop, okay, using the KVL equation. Similarly, if you have, if the four elements are connected in series, and if you know the three voltage drops across three elements, okay, then you can easily calculate the fourth element drop using this KVL method. So from this equation, easily I can write the value of Vx. So Vx is nothing but minus 10 minus 20. So that is exactly equal to how much? Minus 30 volts. Vx is equal to minus 30 volts. Okay, so this is how you need to calculate the value of the voltage across this unknown element. So okay, I'll try to go ahead now. So I'll try to consider one more example to understand the concept of KVL. So it's a 10 volts battery, 2 ohm resistor. Okay, and this voltage I'm giving it as plus minus 4 volts. And let us assume this is something 4 ohms. Okay, so this is a simple circuit what I have given now. Now I need to calculate the value of voltage drop across the resistor 4 ohms. Okay, voltage drop across the resistor 4 ohms. So this is my target. So actually this problem you can solve in different methods. So one method what I would like to tell you, you can make this as simply 10 volts battery, and you can calculate it as R equivalent. Okay, that is series combination of 2 and 4, you will be getting 6, and then you can calculate the current I passing through this, and then once you get back the I, split the resistors into this, okay, two individuals. So this is once again 10 volts battery, and this is 4 volts, sorry, 2 ohms resistor, and this is 4 ohms resistor. Now you can easily, if you know the current I, you can calculate the value of voltage across this 4 ohms resistor. Okay, so this is a broader approach to calculate the value of Vx. So instead of calculating the value of Vx like that, okay, using a simple KVL, easily directly without calculating the current in this loop, that is the advantage of KVL. Okay, Kirchoff's voltage law. So directly you start walking from here, you walking from here, you're touching the negative terminal of the battery, so minus 10, then you're walking like this, you're walking like this, you're walking like this, you're walking like this, then you're touching the positive terminal of the battery 4, sorry, positive voltage 4 volts, because this is a voltage drop. Okay, voltage drop 4 volts across the 2 ohm resistor. So you're touching however the positive sign, so I'm keeping it as positive, then you're walking once again, continuing, and you're touching unknown value plus terminal Vx, and then you're leaving the negative terminal however, and you're coming back to the same point, something like this. That means you need to walk around the loop to calculate the value of simply Vx. Okay, so to go ahead, so which is equal to what the KVL is saying, the algebraic sum of voltage is exactly equal to 0. So from this analysis, minus 10 plus 4 plus Vx is equal to 0. So Vx directly what you can write, 10 minus 4, so which is equal to 6 volts. So the value of Vx is exactly equal to what? 6 volts. So without calculating the current in this loop, easily you can understand or you can apply the value of KVL. Okay, so going ahead with a little discussion about this battery. Okay, so I'll try to make some little more deep discussion about this battery. So what this battery always will try to do, so even in your market you will try to buy a Nippo battery of 1.5 volts, okay, cost around 20 rupees na. So what is that battery will do always, so that we will try to think about. So let us consider this is a battery. The battery, let us assume, even in the market you can find 5 volts battery as well. Okay, the students are doing little projects there, you might be come across this 5 volts battery. So what is the purpose of this 5 volts battery? Okay, so the purpose of this 5 volts battery, I want to take some deep insight, because it is very important to understand KVL once again in the analysis of complex problems. Okay, so now I'll try to consider this 5 volts battery now. So what is the advantage of this 5 volts battery? So let us consider this point is A, this point is B. Okay, so the battery, what it will try to do, always maintains, the battery what it will always maintains a constant potential difference between the nodes, or instead of nodes I can call them as points, instead of points A and B. So how much the battery always maintains a constant potential difference between the nodes points A and B, irrespective of, so this is also more crucial, irrespective of current flowing through it. So irrespective of current flowing through it, okay, irrespective of current flowing through it, has to maintain, strictly it has to maintain the potential difference of 5 volts between the terminals A and B. The logic is very simple. And not only the irrespective of current flowing through it, but also I want to add one more thing, but also irrespective of potentials at points A and B. This is quite interesting, surprisingly. So it is not only independent of the, or irrespective of the current flowing through the battery, so but also it is irrespective of the potential at the points A and B. So you can immediately ask me, so how can you justify these points? So instead of taking a bigger circuit, so and making the things complex, okay, so I will try to take a simple example of this, some 10 different logics I can explain using the same 5 volts battery. So the thing is very simple. If it is a 5 volts battery, okay, between the points A and B, what I am saying, it is irrespective of the current flowing through this battery, na? So the current, let us assume this is current entering is 10 amperes. Okay, what the battery has to maintain? The battery has to maintain a potential difference of 5 volts compulsory. So this is the first important logic. Then once again, so I'll try to go ahead with one more example for better understanding. However, this is plus and this is minus. So if at all the current flowing through this is something 100 amperes. So the same thing I will try to explain with one more logic. That is, I have take one more battery and it is 100 amperes. Current flowing through this is 100 amperes. Then irrespective of whatever is happening, the battery has to maintain 5 volts potential difference across it. Now I'll try to consider one more example. Two examples I'll try to copy here at the same time. If at all the current flowing through this is minus 20 amperes, what is the purpose of the battery? Battery has to maintain same potential difference of 5 volts. Okay, so the same thing, if at all the current flowing through this is what you call it as uh, something that is minus 15 amperes. The same thing, right? So the potential difference between these 2 points, the battery has to maintain how much? So this is the simple logic where I can explain. So irrespective of the current flowing through the battery, so the battery has to maintain a potential difference of 5 volts. Okay, so now the same explanation I will try to go ahead by taking the potentials at the 2 points A and B. So the same example, same battery I'll try to consider, and I'll try to consider different potentials. So how can I explain the different potentials? The potential at this point VA, if it is equal to 20 volts, then the potential at this point must be 15 volts. So the thing what you need to understand, it is a part of some circuit. Okay, so just an example I am saying. So that means the potential difference between these two is exactly, it should be 5 volts. Okay, compulsory. If at all the potential at VB is reaching 15, immediately the potential at VA should be 20, such that the potential difference between the 2 points is exactly 5 volts. Okay, now a little bit I am going ahead. So this is something 30 volts. So compulsory this must be 25 volts, so that the potential difference between these 2 points is 5 volts. If it is 0 volts, then only it should be 5 volts. This is also you should understand. So this is also the potential difference between the 2 points is 5 volts. Okay, so now we'll try to consider one more example. I'll try to consider if it is 0 volts, okay, then what it should be. So it should be how much? Minus 5 volts. That means how will you understand the difference? 0 minus of minus 5 na? So which is equal to 0 plus 5. So which is equal to 5 volts. That means the potential difference between these 2 points is how much? It is exactly equal to 5 volts. Okay, so this is how. So very two crucial examples regarding this battery what I have explained. So battery is basically a thing in which it has to maintain strictly the potential difference of the voltage that is it is defined for. Okay, so that means it is irrespective of the current flowing through it, or else it must be irrespective of the potential at the points A and B. However, all these examples what I have quoted here are taken from some part of a complex circuit. But rather understanding that circuit, so I have given a glimpse of some simple examples here, so that you can easily understand how this battery will try to maintain the difference of potentials, and also how this battery voltage is independent of the current flowing through it. Okay, so with this discussion, so I'm closing this session now. So today in the next class we'll try to go ahead with the concepts of once again KVL. We'll try to do some more problems on KVL. Okay, so thank you for giving this opportunity. This is Dr. Vijaya Babu signing off.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.